A black hole moves across the solar system every 10 years, passing by Earth as well. Why haven't we seen this? It is merely because of the unique characteristics of these black holes, which, in contrast to the giants and galaxy centers that consume stars, do not destroy planets. Instead, primordial black holes may even be the universe's fundamental structures. It may sound absurd, but black holes are continuously passing through the solar system, and perhaps even through us without our knowledge. How is that possible? Primordial black holes are no bigger than an atom, so we could never see them with our own eyes. Even scientists can't really see them with their best microscopes. Instead, they can only study their supposed effects. Scientists assert that tiny black holes have been flying through space since the beginning of creation and are present almost everywhere on Earth, between planets, stars, and galaxies. What happens now when a tiny black hole passes the Earth? In theory, these black holes are so small and compact that they have no direct effect on the majority of matter particles in their surroundings. However, because of their extremely high density, they exert a relatively strong gravity for their size. This is similar to what happens when an atom weighs as much as an asteroid. Despite their weight, these fragments rapidly weigh several hundred kilograms or even tons, and one of these mini holes can reach the mass of an asteroid. Scientists agree that primordial black holes can pass through the Earth without causing significant damage. The theory is that, due to their small size, they are very unlikely to interact with normal matter. However, a black hole passing through the Earth would not be without effect. The black hole would cause a very small local change in gravity. Despite the weight, this would be so tiny that it would hardly be measurable due to its small size and the extremely low probability of direct interaction with atomic nuclei or other matter particles. The black hole would pass through the Earth without swallowing up any matter. However, theory suggests that these mini black holes do not exist by chance, and that they may play a role that has been underestimated so far. Primordial black holes are thought to have formed shortly after the Big Bang, when extreme density fluctuations occurred in the chaotic, dense early phase of the universe. Some scientists suspect that these primordial black holes could be a part of dark matter. If this assumption is correct, then they would be an important component of the universe. After all, dark matter is thought to make up around 87% of the currently known universe. Presumably, there would be slight changes in the Earth's density distribution or minuscule movements in the continents as evidence of the black holes. This begs the question of whether these effects are actually an essential component of matter's functionality, rather than disruptions at all. Today, we still don't fully understand the dynamics of dark matter and are essentially unsure of its existence. If the hypothesis that there are many black holes moving through the universe is accurate, it would give us a crucial hint as to whether dark matter actually exists. Scientists use dark matter to explain effects and dynamics within the universe that cannot be explained by provable means or forms of matter. Our entire cosmology is currently being tested, and some scientists believe that if dark matter doesn't exist, it could be the cause of errors. Scientists hope to soon be able to use incredibly precise measuring instruments to prove the existence of primordial black holes in our solar system and close to the Earth. If they are successful, we would have the first direct proof of the existence of dark matter, which would advance our astrophysics significantly. Since the 1970s, our cosmology has been predicated on a faulty premise. However, if the tiny black holes now demonstrate that dark matter does exist, scientists may be certain that not all of their previous hypotheses and concepts were incorrect. The fact that the phenomenon of small black holes is extremely difficult to prove makes any statements about their true effect on Earth pure speculation. This is an unpleasant fact that we are dealing with, and science repeatedly shows us that it does not know everything. We also have to face the fact that science can deceive us. Because an explanation space is said to be enormous and tiny black holes are thought to be rare and scarce, some researchers assume that primordial black holes are rare. They reassure us by saying that the likelihood of such a black hole directly striking or passing through the Earth is extremely low. However, Other scientists believe that the microscopic organisms might be much more common and possibly a necessary part of the cosmos. Some research does not completely rule out the possibility that if a black hole of that size were to move extremely slowly through the Earth, it would attract matter nearby and raise doubts about the stability of the planet's composition. Critics of Geneva's Massive Hadron Collider frequently assert that black holes are being produced there. This may be done on purpose, but it's also feasible that black holes develop as a result of experiments at the biggest particle accelerator in the world. Scientists want to investigate the nature of the subatomic components of matter by observing the behavior and forces that emerge when they hurl tiny particles of matter at one another at high speeds. When they collide, the matter breaks up into its component pieces. These particles are not really visible. Researchers only observe their effects. This could be the danger during tests that shake the matrix of matter, which could release forces that we do not yet know how to measure, but that could affect visible matter. For example, many black holes in Geneva are allegedly playing God, and critics say that the tests have long since created dimensional portals, or that black holes created on the side are altering the fate of the Earth without our knowledge. Similarly, the tiny black holes could play a role in the overall structure of matter and creation that we currently undervalue. Primordial black holes and their origin are fascinating to study. It is currently thought that tiny black holes pass through the solar system roughly once every 10 years, despite the fact that they supposedly have no noticeable effects or at least no visible destruction. Due to their absence of radiation, these black holes are invisible and can only be found by their gravitational pull, which is thought to be powerful enough to slightly alter the orbits of planets or other objects. One potential finding would be through minute oscillations in Mars' orbit. These minute variations are tracked by extremely accurate measuring tools made possible by advanced technology like Mars rovers and orbital measurement equipment. Over many years, scientists have been able to measure even minute shifts of a few centimeters. If these black holes were already there 13 billion years ago or more, they are witnesses to an invaluable path. If it turns out that they follow a pattern or a specific function, these primordial black holes would be another key to understanding the blueprint of the universe. Despite the most recent studies, studying such objects could help us better understand gravity and matter and provide insights into the conditions of the early universe. There are still questions about whether the theory of small black holes can actually explain the effects, such as the waves or fluctuations in the Martian orbit, which are incredibly tiny and necessitate extremely precise measurements. The effects could also be caused by something other than the search for wormholes. The theory of primordial black holes is intimately related to the fascinating topic of wormholes. We are familiar with the idea from science fiction films, but few people are aware that even accepted science asserts that wormholes actually exist. Some scientists now believe that the minuscule primordial black holes may serve as a type of germ cell for wormholes. According to theoretical physics, wormholes are hypothetical connections between two different points in space or even in time. These funnel-like systems could allow us to cover vast cosmic distances in seconds. The idea is both crazy and fascinating at the same time. It's based on the fact that space-time around black holes is extremely distorted, which may create the conditions for a stable wormhole to form. If such structures exist, they can not only completely change our picture of the universe, but also explain how matter and energy are transferred between distant regions of the cosmos. If we imagine that such wormholes exist not only in distant galaxies, but also directly in our solar system, the idea takes on a whole new dimension. Imagine that primordial black holes, which regularly pass through our Earth, are in fact tiny wormholes. Then there would be direct contact with other regions of the universe, or even in parallel times and worlds right in our environment. Although this idea is currently still officially treated as pure speculation, scientists are actively looking for signs of such exotic phenomena. One hope comes from gravitational waves, which could provide clues as to whether intermediate black holes show serious evidence of a wormhole in their structures. Even though Albert Einstein believed that wormholes were possible, Minute variations in the characteristics of the waves created by events like black hole mergers could indicate the presence of spatial and time gates. The Einstein-Rosen bridge, a mathematically verifiable tunnel that could theoretically connect two distant points in the universe directly, was the result of his research in the 19th and 20th centuries. The real proof of wormholes would not only be a groundbreaking scientific discovery, but also, for practical applications, could lead to advancements in the development of spaceships that could use wormholes or folds in space-time to overcome the dimensions of time and space. This could take us humans far beyond the boundaries of the solar system in a way never before thought possible. Subscribe to the channel now, as the best videos are still to come.